All right, so Unit 6 is on inverse functions, and today's learning target 6.1 is how to create an inverse function. Now, the word inverse, it sounds kind of like reverse, doesn't it? And we've dealt with inverses before. Do you remember when last semester we had a certain inverse thing that we used? We already forgot all of first semester. Like a square grid, numbers inside of it. A matrix! Yeah, remember an inverse matrix? Like to cancel out a matrix, like you wanted to divide by in a way, you'd multiply it by its inverse and it would cancel out. The reason being is because those matrices were like opposites of each other. And that's what an inverse function is in a way. And so certain functions are considered the inverse or just the opposite of other functions. So when you hear inverse, just think it's like the opposite thing. Hello. So a very simplified example of an inverse functions, you can see right here, y equals x squared. If this is a basic quadratic function, the inverse of that would be y equals the square root of x, because isn't squaring and square rooting, aren't those like opposite operations? They undo each other. And so because they're kind of canceling each other out, they're considered inverses of one another. So like the radical function is an inverse of the quadratic function in a way. Now we're going to be dealing with obviously more advanced examples than just a basic x squared, but that's the general idea. And we're going to calculate this. I'm going to give you one function, one equation, and ask you, hey, find the inverse of this function. And so the main idea behind this for an inverse is this concept of basically swapping the x and y values. So like wherever there's an x and wherever there's a y, just switch their locations and then solve for that new y. So like you're putting the y kind of like in the middle of the equation, like where the x was. Then you want to cancel everything else out until you're left with just that y variable, until it's like y equals again. And that'll be considered your inverse function. Just a quick note, you all seen that before, function notation, right? Instead of using y equals, we sometimes use f of x equals. That just means it's a function of x, a function with x being your main variable. You're going to be seeing that notation more and more as you progress through math classes. And so the way we denote an inverse of f of x is f inverse of x. Does that -1 look familiar to you? Do you remember that with matrices? We'd have that little -1 for an exponent. So we'd read that as f inverse of x. So you just put that little -1 there that indicates this is the inverse function of what we started with. All right, pretty cool so far, just in general. I know I haven't actually done any learning yet, but here we go. So here are the steps for calculating it. So go ahead and write down that function in the upper right. F of x equals x minus 3 squared plus 1. So just follow along with me. Don't write everything down right now. Just kind of follow along. Let me put up the blinder. So we're just going to kind of go right through this together as a team. We're like a math team. What? Uncoordinated? Nah, we're good. We got this. So we're going to calculate the inverse. First thing we want to do is to swap the x and y values, except there is no y anywhere in this equation. Eek. Well, remember, f of x, this right here, that's the same as y, right? So if you want, replace f of x with y, and then you're going to rewrite that equation just like this. And notice, the only thing that I did is I swapped the x with the y. Okay, you switch where the x is with where the y is. Write this down. So you're swapping your x and y values. So instead of y equals x minus 3 squared plus 1, it's now x equals y minus 3 squared plus 1. It's the same exact equation, right? But that right there is the inverse step. You're really just switching the x's with the y's. And that's how you kind of get this opposite, this inverse of it. So at this point, you see that our y variable is right there on the right side. And it's got all these other numbers and letters and calculations with it. And our goal right now is to try to get that y all by itself on one side. So I want to basically cancel all this other stuff out. I want to move it all over as if we were solving an equation just for any variable. So if we wanted to get the y by itself, so it just is like y equals, what would I cancel out first over on the right? Now I've got technically three things I need to address. There's this minus 3, there's this exponent of a 2, and there's this plus 1, right? We've got to get rid of all those. If I get rid of all those, then the y would be by itself, and we'd have our inverse function. So which of those do I have to cancel out first? The 1. You get rid of whatever's basically like furthest away from the y. I always think of it. Imagine, and you guys ever seen Shrek? He talks about he's like an onion, he's got layers. You know, ogres got layers. Well, functions, they have layers. You got to start on the outside and work your way in, all right? And then Donkey says, what about a parfait? You know, all right, we'll watch Shrek maybe at the end of the year. So right now, we want to get like the outside stuff gone first. In this case, that would be the plus 1. You always get rid of like whatever's being added or subtracted first, as long as it's not in parentheses, you know, like that 3 I can't get rid of because it's kind of locked in with those parentheses and that exponent. So we got to get rid of that plus 1 first. We're going to do that just by subtracting 1. So our next step, we're solving for y. And the first thing we're going to do is just subtract 1 from both sides. Give me a thumb up if you think you can do this so far. We're good, right? This isn't like insane advanced triple calculus yet. Wait, is it a plus 1 or what's that weird cross symbol in the middle? Oh my gosh. It's plus. Nice. So we got rid of the 1. Yay! But the y is not by itself yet. There's a minus 3 and then there's a square. Now I can't really like get into that minus 3 yet because of these parentheses. And there's a lock on those parentheses, and that lock is this exponent. So in order to get rid of those parentheses, I got to get rid of whatever's just outside of those parentheses, which is this exponent of a 2. And you all know how to cancel out an exponent of a 2, right? What do we have to do to both sides? Just square root it. That's the opposite operation. Squaring a number and square rooting a number are opposite operations, right? 5 squared is 25. The square root of 25 goes back down to 5. So then our next step would be to take the square root to cancel out that exponent. But if I square root the right side, I square root the left side. And do I just square root the x? Or do I have to square root the entire thing on the left? That entire binomial, right? So it's the square root of x minus 1. And then over on the right side, that square root and the square, those are opposite operations, so they cancel out. Da, 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 da. And here's our equation. Am I going too fast, or are we good still? Right? Thumbs up? Yeah. Isn't this a great lesson so far? Piece of cake, right? I knew you'd all get it. One last step. That says y minus 3. What's the opposite of subtracting 3? Obviously adding 3. So then we would just add 3. Oops. To both sides. So that cancels out the 3 over here. And it just brings it there. Now, just be very, very careful when we're writing this with the square root. Notice that the square root kind of stops right there after the x minus 1, right? Because we did the square root first and then added 3. So make sure that that plus 3 is not underneath the radical. So If you have a tendency to write pretty quickly and a little scribbly, you've got to be precise with these. You know, don't extend this or anything, or otherwise I'm going to be like, why didn't they just add 3 or whatever? And that's because that would be incorrect. So make sure you do stop your root. If you want to add something, I've seen people do in the past with the square root symbol, is they'll do this and then put a little like hat on the end of it to indicate this is where my root stops. So if you do have a tendency to get a little nuts with your lines on your roots, if you want to just cap it off, just to make sure that I can tell, hey, this is the end of their radical. They're done. That plus 3 is not a part of the root. Or if you are careful at writing, then that's fine too. So the last thing we would do is rewrite it as the official inverse function. So the last thing is I'm just basically replacing the y with this f inverse of x. All right, so f with that little -1, kind of like an exponent. F inverse of x, and then it's that square root of x minus 1 plus 3. If you wanted to, you could also write this as 3 plus the square root of x minus 1 if you that's a more clear way to indicate, hey, the root is just the x plus 1 part, not the 3. Again, you can always switch the order. It doesn't matter. When you add things, it's commutative. And that's the lesson for today. What do you think? Who's got this? We feeling good? Yeah? Awesome. I know, you're like, Wojcik, wait, come on, man. What's the trick? How are you going to make this more difficult? What? No, I wouldn't do that. Would I? It can't get more difficult than that. Don't worry, that's not until example 4. The first 3 are a piece of cake. First off, any other questions on this? It is honestly as straightforward as it seems. Switch the x and the y, solve for y. You just have to be careful with your order of operations that you're canceling things out from like the outside in, just like an onion. You're gonna remember that, aren't you? On the test, I'm gonna see like little Shrek ears above your name or something. All right, so go ahead and try this one on your own, everybody. Find the inverse of this function. So y equals 2 times the square root of x plus 1, and then a plus 5 after the root. So pretty straightforward. A little bit of the opposite of what we just did. And you're just going to switch the x and the y, and then solve for that new y, just canceling things out. But you just have to be careful in the order that you cancel things out and keep stuff organized. All right, and really take the time to work through these. This is where the learning happens. I don't want anyone sitting there being like, I'll just wait for Wojcik to do it. No, that doesn't help you learn anything except how to copy. And I know you're all good at copying stuff down. Yeah. A Shrek party. Do we have to now? All right, if everyone gets a 3 on target 6.1, we'll have a Shrek party. Does that sound fair? And I want you just to, remember the onion. I want you all to be the onion. A green onion. Might be rotten, though. Okay, so let's go through this together. There's really like 2 steps, Step 1 is to swap the x and the y. So you're literally writing that exact same equation, just if there's an x, you write y. If there's a y, you write x. And so this is going to be x equals 2 times the square root of y plus 1 plus 5. And now our goal is to solve for the y. We want to get this new y variable all by itself on one side, so it just says y equals. What are we going to cancel out first? The 5. Good. You always get rid of the furthest thing away, just like an onion. Usually it's going to be whatever's being added or subtracted. The furthest thing that's away from there. So I'm going to subtract 5 from both sides. So this becomes x minus 5. Please make sure you're doing opposite operations. I know that sounds silly, but I still see a couple students on test being like, oh, there's a 5. Let me cancel out that positive 5. And they do this. I'm like, come on. What? We're not going to do that, right? No one's going to do that. Don't add to cancel out adding. That'll make me cry. Just like an onion make you cry. Okay. Here we go. Equals 2 times the square root of y plus 1. Okay, so now do we square both sides next? No, you can't. That square root isn't quite alone yet. There's like a lock on it. And that lock is this 2. That 2 that's right in front of it. Now, what operation's going on between the 2 and the square root? Multiplication. Yeah, whenever there's something right next to a variable or a parentheses or a root, in this case, a radical, it indicates multiplication. And so to cancel out that 2, that times 2 operation, we're going to divide by 2 because that's the opposite. So I'm going to divide by 2. Over on the left side, do I just have to divide like the 5 by 2 or the whole thing? Yeah, you're dividing this entire left side by 2. 2 divided by 2 is 1, so that just cancels out because it's like then 1 times the square root is just the square root. On the left side, we can't really simplify anything, and so you just leave it as x minus 5 over 2. And that's totally okay. All right, so let me clean this up a little bit. I guess I'll write over here. So we have x minus 5 divided by 2 equals the square root of y plus 1. Now, what are we going to do to both sides? You square it. Since the right side's got a square root, the opposite of a square root is squaring. Now, also, don't just write a square like that because it looks like I'm only squaring the 5. Right? It's that entire left side is all being squared. And so we're going to write it like the whole group, the x minus 5 divided by 2, all in parentheses, being squared. So we've got x minus 5 divided by 2 squared equals y plus 1. And we have one final step to get the y by itself. We're just going to subtract 1 from both sides. Since it's got a plus 1, we just want to subtract that 1 from both sides. But notice that minus 1 is going to be outside of the parentheses. It's not a part of that whole squared grouping. And so we subtract 1, and here, like it's outside of that where I subtract 1. So we've got your y equals the whole big parentheses thing, x minus 5 over 2 squared minus 1. And then you can just replace that y with f. Oh, I need more room. That f inverse of x. Whoop. F inverse of x equals this. X minus 5 over 2 squared minus 1. If you want to leave your answer just like this, that is 100% okay. I'll still accept that. But we could do some more simplifying if you really wanted to, which I'm sure you all do. Like I might just square the denominator to make this look a little nicer. So f inverse of x equals 1/4 x minus 5 squared minus 1. So I basically just squared the denominator, and then that'd be a 4. And then dividing by 4 is the same as multiplying by 1/4. So I just moved it into a coefficient position. That just looks a little cleaner. Have you seen an equation like this before, first semester? Anyone remember what this form is called of a quadratic equation? Yeah, that's vertex form, right? That's a parabola. Where's the vertex of that parabola? Remember, you flip the sign of the number in the parentheses. So the vertex would be at 5, negative 1. So close. And then that 1/4, what's that 1/4 do to our parabola? Slope. Good, just say random words, you know. What's that 1/4 actually do to the parabola? Arithmetic. What's it going to do? Thinner. So that's like a stretch or a compression. So 1/4, since that's less than 1, it actually will be a shorter. So it's like a vertical compression. And so the parabola will go up 1/4 of its original height. So it'll be like a really wide kind of parabola. Is this parabola going to open upwards or downwards? Is A positive or negative? Like look in front of the squared term. That's a positive 1/4. That means it opens in the positive direction, so it opens upwards. I know you're like, Wojcik, I don't need to remember that anymore. I learned it last semester, so I can forget it now. That's actually the opposite of learning, though, isn't it? So I'm not going to test you on that, but I hope that it's kind of parts of that are still in your brain a little bit. Whew. All right. By the way, how many of you had at least the part that I have in red? Did you get that far? At least you don't have to have done the fancy stuff at the end that I did, but if you got at least to that first inverse function, and that is awesome. Yeah, you don't need to do that. I'm totally okay with the x minus 5 divided by 2 squared minus 1. You found the inverse function. Good job. Number 2, find the inverse of the function below. I know you're like, wait a minute, Wojcik, that looks way too easy, right? Just be careful with the order that you cancel things out. So y equals negative x cubed minus 8. To make this a little easier for you, I would suggest writing it as y equals negative 1 x cubed minus 8. Just by putting that 1 in front might help you understand what to do a little bit better in the order that you cancel things out. Nice. We'll take a look in a minute. Did everyone attempt it? You have to at least attempt, right? You got to try writing something. It's okay if you make a mistake. I do it all the time. Like deciding to be a teacher. Nah, that's a joke. I love teaching. All right, so we switch the x and the y. X equals negative y cubed minus 8. And there are no parentheses here. And I always say start from the outside, work your way in. So think about like what's the furthest thing away from the y? And I see it looks like the 8. It's kind of like that minus sign almost pushes it away, like further away from the y. And again, you always kind of cancel out whatever's being added or subtracted, like the outermost thing. So in that case, that's that minus 8. So we're going to start by adding 8 to both sides. X plus 8 equals negative y cubed. How many people got at least this far? Added 8. All right, all right. So now there's a negative sign and there's an exponent. Which of those do we cancel out first? The negative or the exponent? Negative or the exponent? If we think of that negative being like negative 1 times y to the third power. The way we cancel things out is really the opposite of PEMDAS. You know, it's the opposite of the order of operations. So instead of using PEMDAS, we use SADMEP. And so, please don't tell other math teachers that I'm showing you this. It's not a real thing, but it helps me a little bit. You get rid of whatever's being added or subtracted first, which we did, right, with the 8. The next thing you want to cancel out is anything being divided or multiplied. In this case, that's going to be that negative 1. So the negative 1 is the next thing we're going to cancel out. After that, you get rid of any exponents, and then if there are anything in parentheses left, then you adjust that last. So I need to get rid of this negative 1 in front of the y. Should I add 1 to both sides since that's the opposite of a negative 1? Well, we're not subtracting that 1, right? That's a negative 1 times y squared. That's being multiplied with the variable. So to cancel out that negative 1, we need to divide by a negative 1. Doing so will cancel out, and leave us with just the y cubed. Now on the left side, I have x plus 8 divided by a negative 1. Whenever you're dividing, if you can divide each term nicely by that denominator, you should. The previous one, we were dividing x by, was it a 5 or something? And that doesn't really work, or a 2. That's what it was. And that doesn't really work out. But dividing by a negative 1 is pretty easy. If I divide x by a negative 1, it just becomes a negative x. If I divide 8 by a negative 1, it just becomes a negative 8. So I'm actually going to switch the signs of both of those on the left. It's going to become a negative x minus 8 equals y cubed. All right, so instead of keeping it as a fraction, I'm going to actually divide it out because I can. Nice and easy here. Last thing to get the y by itself, I see y with an exponent. So do I just take the square root of both sides now? Not a square root, because that's not a 2. This would be a cube root because it's being cubed. So a cube root, it looks like a square root, except there's a little 3 in the nook. So you've got to take the cube root of both sides. So it's the cube root of negative x minus 8. Doing so will cancel out the exponent, cancel out the root, and I'm left with just a y, which we would write our final answer as f inverse of x equals the cubed root of negative x minus 8. Did anybody get that? The cube root of either x plus 8 over negative 1 or dividing it out with a negative? Okay, so we're all there. It's pretty cool. One thing though, can I take a cube root of a negative? Is that allowed in math? Wait a minute, is it? Is that actually a negative number under there? What if x were negative 100 and I plugged it in? Would I be taking a cube root of a negative number? So then that would be like a negative 100, which is a positive 100. Then it'd be a positive 100 minus 8 is positive 92. So this is allowed, actually, because it's not actually the cube root of a negative, because if x were a negative number, a big negative number, bigger than a negative 8, or bigger than 8, then that would be positive. That radicand, the part under the root, could still be positive. And one other thing, we are allowed to take odd indexed roots of negative numbers, just not positive roots. You know, because if I took a negative number to the third power, it would still be negative, because it's like a negative times a negative times a negative again would still be negative. So you could take the cube root of like a negative 64, and it would be a negative 4. So yeah, this is totally allowed. That is absolutely our inverse function. Bum-ba-da-bum. Doing okay so far? Got two more. One easy one, and then another one that's gonna knock your socks off. So I hope you're wearing flip-flops. Not yet. Find the inverse of this function. This is called a rational function because it's a ratio. The x is in the denominator. Just take a minute, swap the x and the y, and just take your time canceling out each piece one at a time. You wrote sad map. What do you do when the variable's in the bottom, though? That's the thing about this one. We're not solving for 1 over y. We're solving for y. So you need to figure out how to get rid of that. So if we swap x and y, we get 1 over y minus 2 plus 4. And the first step, I'm sure you all got, and the next step, we just want to subtract 4 from both sides. So x minus 4 equals 1 over y minus 2. So here's where we kind of get stuck. Because, like, I can't just add a 2 because this is in the denominator. And furthermore, this is a binomial. Technically, it's like in parentheses. It's grouped together, you know? And so I've got to figure out how to get that out of the bottom, how to get that out of the denominator. I can't have y in the denominator. It needs to be up in the numerator because we always have our functions as y equals, not 1 over y equals. Typically, if something's in the denominator of a fraction and you want to cancel it out, what do you do to both sides to get it out of that denominator? You multiply. Very good. So this binomial, this y minus 2 is in the bottom. It's in the denominator, and I want it to be out of there. So guess what? Let's multiply by that exact binomial. Let's multiply by y minus 2. If I do this, will those cancel out? I'll get the y out of the bottom, right? But if I multiply the right side by y minus 2, I am going to have to multiply the left side by it. Now, the left side already has an x minus 4. What you want to do is make sure that you keep this in parentheses as well. That x minus 4 is its own like binomial. It's its own grouping. But I'm now multiplying it by this y minus 2. Now, don't FOIL those or anything. Leave them like that. We're going to get rid of that x term in just a moment. Whoop. But by doing this, we now have this y minus 2 times x minus 4 just equals to 1, right? That 1 is the only thing on the right side now. But that's okay. I know this looks really weird, but we had to take that step because the variable we were solving for was in the denominator, and we can't do that. We can't leave that variable that we're solving for in the denominator. I needed to bring it up top, so I multiplied by whatever it was with in the bottom. So is the y in the numerator spot now? It is. It's no longer a 1 over y. It is just there's a y. So our next goal now is to get that y right there all by itself. And right now, these are being multiplied together. What do you think I should do next? Yes, what am I going to divide by? Is x allowed to be in the denominator? Can we have the x variable in the bottom? Sure, isn't that actually like what we started with? Right, up there, that one, it had an x in the denominator, so that is okay. And so what we're going to end up doing is dividing by this x minus 4, because I'm trying to get the y all by itself. Let's get rid of the other stuff. So that means I'm going to divide this side by x minus 4. And on the left side, those two binomials cancel out. And now it's pretty simple because I have just a y minus 2. Right, this is now y minus 2 equals 1 over x minus 4. I know that's a tricky step, but it's not complicated. It's just probably something you haven't seen before, but it's still valid algebra, right? You multiply to cancel something out, or you divide to cancel something out. It's just instead of for one term, we did it for that whole binomial, that whole little mini polynomial. Final step to get the y by itself, well, we can just add 2 to both sides. But would I add that 2? We have to be careful. Am I going to add it like up here with the 1 and write 3? No, because this is a fraction, right? So it's got to be completely like separated. whoops, off to the side over there. So then my final inverse function will read f inverse of x equals 1 over x minus 4, all in the denominator. But then this plus 2 is just kind of hanging off to the side of the fraction, right? You would do that whole fraction math first, and then you would add 2. And that is our inverse. Dun, dun, dun. I know, it's tricky. I'm trying to trick you. Now, just the more of these you see, the more skills or techniques you're learning, the more diverse your problem solving becomes. Oh, and remember, this is still one of the easy ones. You want to see the killer one? All right. Are there any other questions on this first, though, before we move on? And I crush your souls. I mean, challenge you. We're okay? There we go. Hey, have fun. I'll give you about, I think 40 minutes is enough to solve this, maybe? Yeah, I'll give you about 40 minutes to solve this, and then these are like 10 minutes for homework. I'm kidding. I'll give you 45 minutes. To help you along, I'm going to remind you of some basic properties of exponents. If you have an exponent raised to another exponent, you multiply them, right? X to the second to the third would be 6, because 2 times 3 is 6. Another thing I want to remind you of is if you ever want to cancel a fraction out, like a 2/3, for example, by multiplying, you would multiply it by its reciprocal. So see if you can piece those two pieces of information together to cancel that out. You what? Yeah, dive in. The water's fine, although it's probably frozen because we live in Wisconsin and it's January. No, it's February. What's today? The 2nd? Today's tutu. I see none of you wore your tutus. Disappointing. Are you sure? Yes, sir. You think you got it? What? That didn't take 45 minutes.
No, I just think I missed
What's the opposite of adding to?
something.
Yeah.
I did it up here, and then I just switched it.
Man, it's like I specifically called out everyone's attention to that. You'd have to get rid of the 5 before you get rid of the 3.
I do?
Mm-hmm. Think of SADMEP. Division comes before exponents when you're canceling stuff out. But excellent work. How do you cancel out that 1/4 exponent? Not quite, no. So you're going to not multiply by something that's already there. Just like on all these other steps, we started by adding something else, right? To get rid of a -8, you added 8. There wasn't a +8 already there. You did that. So you're going to do some operation to both sides to cancel out that 1/4. So what power could you raise 1/4 to so that it cancels out? Think 1/4 times what number? 1/4 times what number cancels it out? And that will be the exponent that you're going to want to raise both sides to. So yeah, please don't take a 1/4 root. Don't do that. Think more canceling out exponents. Yes, sir. Nice job. He did. He probably just listened well.
I got this, but I think that's
Oh my gosh, it's super duper close.
wrong.
It's not going to be the 1/4 root of x. Instead, write that as x to the 4th. Technically, that is the correct, like you did everything in the correct order. It's just whenever you have a rational exponent, we can't cancel it out by taking a root, because a rational exponent is a root. So it's like you're doing a root of a root. And so you want to raise it to a power. I'm sorry. Yeah, that works.
Is that right?
Yep. Wasn't a guess. You had a little bit of insight. Huh? You're close. You need to get rid of the 5 before you get rid of the 3, though. Dun, dun, dun. Thinking. Not for this target. For Friday's target, you do, because that target is showing each step, showing the process. Yeah, if you got it in your head, if you can kind of analyze it and be like, oh, so it'd be the opposite of this, that's fine. But just know without your work, if it's wrong, and I don't know where you got it, you're going to get fewer points than if I could follow along and be like, oh, I'll still give them a point for this or this. Dun, dun. Why, yes, it is. So it's kind of fun, right? It wasn't that bad. I mean, left to your own devices, maybe it would have taken a very long time, but once you've seen it, it's not too bad. Graphing. Don't worry, we're graphing tomorrow, so that's fun. It's very fun. All right. So if I look at this, there's one set of parentheses, and mostly everything's inside those parentheses. So I know I'm going to need to get in there eventually. But in order to get there, I got to cancel out that exponent of 1/4. That 1/4 is like the lock on the parentheses. You got to get rid of it. So to cancel out this exponent of 1/4, I'm going to raise everything to the 4th power. Because whenever you have an exponent raised to an exponent, you multiply them together. And 1/4 times 4 equals 1, meaning it will cancel out. So by doing this, oops, I forgot to swap the x's and the y's. My bad. Really, Gavin? So we have x equals, well, this will be x to the 4th equals x cubed over 5 plus 2. This is technically by like being 4 over 1. And so you raise that side to the 4th power. You're raising both sides to the 4th power. When I raise the right side to the 4th power, I technically distribute it to each term in there, but this parenthesis acts like one term. It's as if there's only one thing being raised to the 1/4 power. And so I just have to multiply 4 times 1/4, which is 1. So these both cancel out and leave me with just the, oh, I'm sorry, that's supposed to be a y. I messed up again. I'm terrible at this. Child, watch it. All right, so there's your first algebraic step. You're going to see problems like this again. Something's to raised to a rational exponent. You're going to raise both sides to the reciprocal of that fraction, okay? Because any reciprocal times itself cancels out. So on the right side, the 1/4 canceled out. But on the left side, we still have this 4. So what's just an x? It's now x to the 4th. On the right side, I still have 3 items I need to cancel out. The 3, the 2, and the 5. What are we going to cancel out first? The 2. Right? The 2 is being added or subtracted. Go for that next. So we're going to subtract 2 from both sides. That leaves us with x to the 4th minus 2 equals y cubed divided by 5. And then this next step is where I saw most students make an error. Do you get rid of the 3 or the 5 first? So the 5 is actually being divided, right? Like that fraction bar means division. That's y to the 3rd divided by 5. And according to SADMEP, you want to cancel out whatever's being multiplied or divided first, and then save those exponents for later. So I'm going to cancel out this divide by 5 by simply multiplying by 5, although I would need to multiply this side by 5 as well to keep the equation balanced. These cancel. Too far. And we'd be left with 5 times x to the 4th minus 2 equals y cubed. By the way, if you were to distribute that 5 inside the parentheses, that's totally okay. So if you have 5x to the 4th minus 10, same thing. They'd be an easy multiplication to do. Last thing, this is y to the 3rd power. How do I cancel out that exponent of a 3? You do a cube root, a 3rd root essentially, you know? And so we would say our final answer, f inverse of x equals, the whole thing is in a cube root. Cube root of 5 times x to the 4th minus 2. And you could also write this as 5x to the 4th minus 10. If you just distributed that 5, same exact thing. And so if you did that, that's perfect. Unless your name is Gavin, then you already were perfect. Good job, you did it. All right, quick room assessment on your understanding. Can I get a thumb up, thumb down, or thumb to the side if you're somewhere in the middle? Otherwise, you're like, all right, I think I can do this. I understand the basics. I just want to practice a little. Thumb to side, like, I followed some of it, but some of this is going to trick me. Thumb down is like, where am I? What class is this? Okay. Wonderful. Well, now, to help you practice this, let me show you some fun things that I've got in store for you. Have you heard of this site before? It's called Delta Math. It's cool because delta in like science and stuff, the symbol delta actually refers to a change, right? If you take in physics, like delta y means a change in your y. And so delta math means it's going to change your math because it's going to make you so good at it as opposed to where you were before. Gosh, that actually sounds kind of rude. I apologize. That's assuming you're terrible at math right now, which you're not. You're all great. So first off, are you all okay with multiple choice? Because these are all multiple choice questions. I know, it's crazy, right? So you got multiple choice here, and I want you to find the inverse. Now, I strongly suggest you use your notebook and you write this stuff out, right? Write it down. I'd probably write it with the opposite x and y right off the bat. And then, okay, what I cancel. Don't try to like guess, all right? Please don't. I can tell when you guess, all right? I think we had like 2 multiple choice assignments first semester, and I can see your progress, and I can tell when that person just like has like 20 wrong answers and like 1 right, and then like 20 more wrong ones. It's like, okay, you just clicked A like every time hoping to get it right. Don't do that. Take your time, work the problem. Silliness. And they just progressively increase in difficulty. So this is going to be really good practice for you. Just more and more steps. Oh, look at that one. That's awful. All right, so this is rare that you get class time to do your homework, but you must be productive. You've got over half an hour, okay? Some of you didn't even do the homework from last week. That is a crime, and that makes me cry, all right? I shed tears this weekend because I tried to emphasize how important it is to do your work daily. And some of you couldn't. Some of you couldn't even sign into Delta Math yet. You're all pretty good now. So I am giving you lots of time to practice right now. Let's see what you can do. If you get stuck, feel free to chat with a neighbor or check your notes. You got this.